Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Hello, welcome to this next video in object-oriented programming Python with coding-bootcamps.com. The rest of the videos in the course are going to be projects, all covering class concepts. We may get to a few other class concepts, but only as they come up in projects. So the first project, we're going to create a car class with 3 subclasses, and the subclasses will be sedan, convertible, and minivan. And we want to make a number of attributes or variables or member variables that go with each of those classes, some methods, and we want to practice some things such as overriding functions, adding functionality, things like that. So I'll just put everything I want in the program at the top. So for project 1, create a car class with 3 subclasses. Subclasses sedan, convertible, minivan, that each inherit the car class. Create a static variable inside of the car class that says something about all cars. So a static variable, if you remember the example we had before, the dog, would be like this line that says species Canis familiaris. That's a variable that you define a value for in the class that isn't related to a specific instance, but it's related to the class as a whole. And it helps describe something about that class object. So all dogs have the species name Canis familiaris. You can define the name of the species in the class because it's not going to change from object to object. And basically static variables, they're defined they're not exactly defined once, they're kind of defined in general for an entire class. So yeah, I wanted to create at least one static variable for all cars, so just create a static variable that defines cars that you wouldn't want to be related to just one instance of a car. Static variables are not defined when an object is created because they are not in the class constructor. Instead, they're in the main class. They're just in the class. And describe the class in general. Create at least 4 variables that describe the car, such as name, model, mileage, things like that. Come with your own. Create at least 3 member functions. Member functions or methods that use the car's class member variables. I want at least one of the methods to be overwritten in your subclasses, and at least one of the methods should take the parameter that isn't defined in the class constructor. So at least one method should take in parameters. At least one method should take in parameters that are not in the class constructor, and at least one method should be overridden. Actually, I'll put it below. Override a method at least once in each subclass, and expand on the function definition in each subclass. Also include at least one new method in each subclass. And then finally write some code to test your classes and create at least 4 objects. 4 objects or instances, one for each subclass and one for the parent class that to test all of your class code. Okay, so this is the first project. It's a basic introduction. Some of the later projects are going to be bigger. Especially, we should have about 3 or 4 projects, and the last one will probably be the biggest. I think for the last one, I'm going to finish the blackjack game I made below. That's going to be a much larger program. Or we might only, we're going to do anywhere from 2 to 4 projects, depending on how long they take. So if you want to not see my solution, I would pause the video here. And right about now, I'm going to start creating my own class for this project. Okay. So for my car class, I'm going to start with class car. We want 3 subclasses. Put pass for now. We want 3 subclasses, and I'm going to name them sedan, convertible, and minivan. And then I want to create a static variable inside the car class that describes all cars. I was thinking maybe just calling them vehicles. Or I'll just say the size of the vehicle, or vehicle size. You can come up with anything you want. It's not particularly important if it's useful. I just wanted to show a point by making a static variable. And we can test that later. So vehicle size, small. So I wanted 4 variables that describe a car, so I'll just use the ones I made above. So we need our initializer, constructor, name, model, mileage, and just put color. Self.name equals name, self.model equals model, self.mileage equals mileage, and self.color equals color. Those are our 4 variables, and then we want 3 member functions that use the car class as member variables. So I guess I'll come up with a print function. Model. Print. name and model are kind of the same thing, so I'll give it a name. Instead, I'll put like license plate number. License plate number. By the way, if you're using an IDE, most of them, when you're in the process of typing a variable you've already defined, like license plate number, a window will pop up as you're typing it, and then if you press enter, it'll automatically fill it in. So just a quick shortcut. I haven't figured out how to clean it off yet in Python, but I'm not concerned with it. So define print model. Model is a car. Two more. But I'll do miles to kilometers. Do model this self model as mileage string. Another thing is, just really quickly, if you're defining variables, because Python automatically types variables and you can't explicitly do it, meaning if you assign a value to a variable like a number, it's automatically going to make that an integer or a float. When you're coming up with messages, you have to type it as a string and not throw an error. Something really quickly. So if I didn't have the string in here and I assigned a number to the mileage value, then without this string, I'd get an error for this function. Because you cannot add numbers in Python to strings, because it won't know what to do with the addition operator, whether to concatenate it or add it to the message or try and like do mathematical addition. So this model has miles on it and which is string mileage times 1.6 kilometers. And then the license plate number.
Thanks for watching. Feel free to add your questions as comments down below.
I just did a bunch of print statements. in the next project we can do less printing of messages and we can do a lot more trying to come up with more meaningful functions that like work with numbers and things, but for now just do print statements. Print the license number of this model okay, so we have our 3 methods, we have our 4 member variables, and let's say we wanted, okay, so we want one parameter that is not in the class constructor. I'll put it in model. Actually, I'll just, instead of this function, I'll just make a I'll make a 4th function. I'll make an add mileage function, and it'll take in a parameter additional mileage. So add mileage. Self add mileage function. So mileage. Then do self dot mileage plus equals more mileage. Okay, so now if I use the add mileage function, I can add on some mileage with the car. Okay. And then override a method at least once in each subclass, and then also include at least one new method in each subclass. So for sedan, should probably override the model function, so we'll do this. Convertible. Alright, it is sedan. And then if we made just a general car that wasn't one of these 3 types, then like a pickup truck or something like that, then we can just print out a general message that just says to make the car. Okay, and then to override it, don't actually add anything. So you don't need to use the super function to override a function in the parent class. It's just if you want to reuse code, but we're printing out an entirely new message. So we could do it like this instead. Do print super dot print model. Or super dot print model plus star is a sedan. So now we'll print two messages instead. Convertible. And then I want one new function for each of these cars. Sedan. I'm gonna look up some car models real quick. It's hard to think of functions that would be useful for one type of car versus another in terms of like sedan versus convertible. For convertible, you can just put or this car. Or old 7. Not 7. Change the names of the functions. Okay, so we overrode, we have 3 new functions. We overrode the print model function to include additional information about what type of car it is, and then we also have the base class, which has 4 numbers in it. So now we need to test all of this to make sure that all of our code works. So to run it, I'm just going to print model on 4 cars. Let's say car equals car. So it's model, mileage, color, and license plate number. So 2021 Ford F-150, and that'll be our general car. Put mileage on it, 30,000. Let's put color and license plate, silver, and then make up a license plate number. AEY, numbers, I'll copy and paste this. New sedan, new convertible, and new, actually I'll name them after the models. So do Ford F-150, the sedan, Toyota Corolla. I'm not good with cars, so I don't really know car models. Toyota Corolla. Just 50,000. All these. Blue, black, and white. Numbers. Okay, and then to the Corolla. Ford Mustang. And then our last type was a minivan. Honda Odyssey. Okay. Ford Mustang, and then Honda Odyssey.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Okay. So So we have our 4 objects, and now we need to test our member functions. So the first thing I'm going to do is I'm going to use the print model function on all of them. Model, 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 model. Okay, so we printed out the makes of the cars. Okay. Oh, that's what I'm missing. I'm missing. Not to inherit card. One. Card up vehicle size. Not card up, but vehicle size. Ford 50. Vehicle size. Okay, I just put small for all the cars, even though it's a truck, but as opposed to like an actual truck, like a 10-wheel truck or something. So we have the 4 print models. We got to change it so it overrides. We don't need to use a super function, but I'll just recomment the statement. Okay, so we have prints. Okay, that doesn't make sense. Okay, so it's not inherit, it's not using the overridden function. Just let's put it back. Just do super print model. leave this one so we can test, and then just change. So for sedan, we should have a model number, Corolla, line 90. Oh, I figured out what I was doing. Make them all car objects. This is sedan. This is convertible. And then this is minivan. Okay, so as you can see, the Ford F-150, you only have the make of the car being printed, but for the Toyota Corolla, the Ford Mustang, and the Odyssey, we also print an additional message saying they're a sedan, a convertible, or a minivan. Also, to reuse the code, we use in the parent class, we use the super function, so it's super.printModel. So super.printModel will go back to the parent class. It'll fetch the printModel function from this class and reuse that function in a new function. And we created 3 new functions, so we've got to use those. So these 3. Sedan, convertible, and minivan, run, put some line breaks. Okay, so we printed out our static variable, which says the Ford F-150 is small. We printed out the make of the Ford F-150, and it's just a car object, since we didn't make a truck class. So it just says the make of the car is Ford F-150, and it doesn't say anything about it being a truck. So we just defined it as a car. Then we created a sedan, a convertible, and a minivan. And for each of those, an additional message is printed out saying what type of car they are. And then we printed out some information about what a sedan is like, what a convertible is like, what a minivan is like. And all of our code is working, which means our classes work. Inheritance is working because we overrode a function. And they're able to use the same variables. So I'll print out one more thing. I'll print out the license number of all 4 cars. This. That was the only thing we need to change. So, Mustang, and then Honda Odyssey. And we're going to do license number. Or actually, I'll do something that we don't have a print statement for. Just do mileage. So this will print just the mileage in miles, not in also kilometers. And then there are mileages printed at the bottom. So we were able to access the variables that we defined in the parent class from the subclasses. So yeah, that's project number 1. It's a very basic program. I'll probably do one more project that'll be a little bit bigger, and we're going to build a sample blackjack game. And in that, we'll actually be using card object, a deck object, and create a main function which plays some of blackjack. We won't create a full blackjack program. We'll just have some basic gameplay in it. Because it would take way too long. It would take several hours. But yeah, this is project number 1. I hope you came up with something similar. If you want to get extra practice, you can add extra functionality to the different classes. You can try adding new classes. You can try adding a class that inherits one of the subclasses, so something that inherits minivan. Just whatever you can do to mess around with it and get more practice in Python. So yeah, next video will be project 2, and thanks for watching. Bye. Hello, welcome to the next video in our Python object-oriented programming course. Today we're going to cover project 2, which is going to be a classes-based version of the rolling the dice program in our intro course. Just before I get into it, I put a couple links at the top. The first link is a link to our one-to-one tutoring for object-oriented programming in Python, and then the second link is for software design and engineering. So if you want to check out either of those, let me change the window a bit. These are the 2 links for them, and we do offer one-on-one tutoring for these subjects. So you can check them out, but right now I'm going to get to the video. So before we can start coding the program, you're going to need import random so that you can choose a random number, not between 19 and 20, but between 1 and 6. So to get a random number between 1 and 6, you put in the parameters 1 to 7. So this means if you import random, this print statement is going to print a random number between 1 and 6, because it's between 1 and 7, but not including the 7. So if I just ran this line of code a few times, you'd see a number 1 down here, and number 5, number 4, but it's always going to be between 1 and 6, because it doesn't include 7. And then 1 is the starting parameter, 7 is the stop parameter, and again, not including the 7. But just to get to it, there's only a couple things we can make a class for, and that would be the players and the dice. It's a very simple program. So the project is a 2-player game. Each round, both players are going to guess the number on a rolling dice, and the player that guesses the most number of times wins the game. The program starts by asking the players the number of rounds the game needs to be played. So let's do this. Let's do rounds equal, let's just code the game first, and then we'll code the classes.
Thanks for watching. Please like and share this video.
Rounds is input how many rounds of rolling the dice do you want to play? we could do a for loop. So for x in range rounds, do play game. We'll make a play game function that plays the rolling the dice game, and then we'll run it through a for loop for each round. So that would be the best way to organize this. So we'll do play game. We'll define a play game function. Oops. Okay. So for play game, player A is asked to guess the number between 1 and 6, and then player A gives the input, and then the dice is rolled by a program. In this case, the dice is a random function which generates a random number between 1 and 6. Okay, this is where we're going to need our random function. If the dice roll generates the same number which a player guessed, he receives a score of 1, else he gets a score of 0. Then player B is prompted to enter the number, and the dice is rolled, and he scores above. And that's a round. So you get 1 point for guessing the number correctly. You get 0 points for guessing incorrectly. And whoever has the most amount of points wins. Okay. So might just write some pseudocode. Pseudocode, if you don't know that term, what it means is you write kind of like placeholder code to just get an idea on your editor, and then you modify the code later so that it actually works and properly and is organized. But so play game will have the wrong comment. Player A, ask player A for a number, roll dice, 1 point if correct, 0 points if incorrect. Then we'll ask player B ask player B for a number, same thing, 1 point if correct, 0 points if incorrect. And then we'll add the points to the player total. Okay. And then outside of play game, we'll have this. We'll have an if statement. We'll have an if, an elif, and an else. So if we'll just say player A has points is greater than player B. And again, this is commented because it's pseudocode. It's not real code. It's just putting an idea in the editor, and then we're going to write the code for it later. So if player A has more points than player B, print a message. Player A wins. I'll put this commented too, because we can like add names and things like that to the player class. So player A wins. And then this will be player B wins. And then player B wins if player B's points are greater than player A's points. I'll just keep be in the same spot, change this. And then else, which would be equals, print the game ends if a tie. And we don't need to put that in pseudocode because we don't need to. We don't need to change that message depending on player names. Okay, so the play game function is going to be at the bottom, and it's just going to play 1 round. I'll rename this to playground to make it more clear. And then this will be at the end of the game, which will print who wins. And then the for loop will be to play as many rounds as you want. And then at the top, we're going to have to define our classes. So we need a player class, so class player. And then we need a dice class, so a class dice for our player and dice objects. So we need to get our constructor. So I think we only need to define one variable, which is the faces of the die. So we'd have self dot face array equals 1, 2, 3, 4, 5, 6. And then actually I'm going to make this a static variable because it doesn't need to be defined in the constructor. And then for player, we want a name for a player, and we want a point count. So we'll have self.name, we'll have self.points. So name is name, and then points is points. And then dice is just going to have face array. Then we can have a print function that says how many points you have. So and name has points. I'll put that into a string. Self.points, self.points, self.name. So player name has points and then many points. Or I'll just put the points. Okay. So this function, if we call it, is going to print how many points the player has. And then each player object has a name and has a number of points. And then we could have we really don't need a lot for the class. This is a very simple program. But you can definitely go back after the program's finished. You can definitely go back and add to the classes if you want to add extra functions, or if you want to make the game more complicated. Okay, so this is just going to be if. Okay, so we need to take in the player names. So create two player objects. Player 1 is input. No, it's just a player object. To this player. And then we can input the name. Player A, please enter your name. /n is new line characters. That means skip a line. So I'm just putting a couple. I'll put one skip line. So it's more clear when we're asking player A for their name and player B for their name. So player A, please enter your name. We'll copy this for player B. Player B, please enter your name. Okay. So we don't need this. Okay, so we okay, so we import random just because the code is all over the place a little bit. Because I wanted to code the main program first and do some pseudocode. We import random because we need the random function to pick a random number between 1 and 6 for the dice rolls, and then the game is played by seeing if the player guessed the correct number out of 6. So we need random to be able to pick random numbers. We have two objects in the program, which are the player class and the dice class. So a player has a number of points and has a name that you ask for, and then the dice just represents the dice object, which is used to play the game. The game starts by we ask the players for their names. So so we ask player A, please enter your name, and this is a parameter. And see how it's inside the parentheses of the player object? That's because it fits the name parameter. So we also need a number of points. So the player is going to start with 0 points. Each player is going to start with 0 points. So this whole input is the first parameter of this player object. That's why there's a comment here. And then this input statement, what it's going to ask is it's going to ask the player for their name, and then it's going to put it in for that parameter, which is the name of the player A. Then we do the same thing for player B. So we just created two players, and then they enter their names, and they start with 0 points. So now we need to ask them how many rounds they're playing. And then let's say they enter 10 rounds, and then we play 10 rounds of the game. So we go through a for loop 10 times, and each time we play a round. And then we had the three conditionals. If player A had, we should make player A. So we had this. We had if player A's points is greater than player B points, player A wins. If player A has less points than player B, player B wins. And then if neither, which means they're equal points, the game ends in a tie. By the way, elif is kind of it's the keyword for else if in Python, which means instead of just a regular if-else statement, it's if-else-if, and then the else-if is like a second out of 3 or a second out of 4. So this is like...
Thanks for watching. Feel free to add your questions as comments down below.
So if you have if, elif, and else, if is the first statement, else the last, and then anything that goes in between would have an elif. So if you had 10 conditionals, then the first one would be if, the last one would be else, and then the 8 in between would be elif. But we only have 3, so we only have 1 elif. But So we say if player A has more than player B, player A wins. So the message we're going to print is player A is player 1. So we'll do, it should be lowercase. So we'll do we'll print player 1 dot name plus wins the game, and then we'll copy this down here, player B. So player B is player 2, and then the conditions would be player A has more points than player B. So this would be player 1 dot points is greater than player 2 dot points. And we can copy this over here, and then just reverse the sign, and then else it's colon, game ends in a tie. Okay. And then we need our play round function, which is you ask player name for a number. So input player1.name. Please enter a number. Number guess. Roll the dice. I'll just put a number guess. We'll do an if else. If that should be stored in a variable, so it should be player guess. So if player guess equals do another statement. Print the die is rolled. Die for singular dice. The die is rolled, or the die rolls the number plus rand range, random dot rand range. So 1 to 7, just like before. Store that in a variable. So we'll do die roll. Okay, so we roll our die. It's a number from 1 to 6. We store it in die roll. Then we print the message. The die rolls the number plus die roll. Okay. So we roll a number from 1 to 6. We print a message to tell the players what was rolled. And then we say if player guess is equal to die roll, player 1 dot points plus equals 1. And then the else would be, actually we don't even need the else because we can just keep the score the same. So they get 1 point if they guess correctly, and they don't get anything if their guess doesn't match. So we can copy this code. For player 2. We can reuse the same player guess variable. So we ask player 2, please enter a number. And then the die roll is the same. Die roll is the number die roll. And if player guess equals die roll, player 2.points plus equals 1. And again, plus equals means take the total that's in player 1.points and then add 1 to that total. So that's why it's not just plus, it's plus equals, because you're taking points, you're adding 1 to it, and then you're putting it back in player 1 points. You're doing the same thing down here with player 2. It's shorthand. So our play round function, we ask each player for a number, and then we add the points. So we don't need the pseudocode anymore. And then we should probably print a message saying we should have an else. Player 1 dot name scored a point. And we can do the same thing. These is player 2. Didn't score any points. Didn't score any points. But without an exclamation point. Okay. So our play round function plays 1 round of the game. So we have a player guess function. Player 1 enters their guess. We roll a number from 1 to 6. The die roll is the number, whatever. If the player guess is equal to the die roll, give player 1 a point, and then print a message saying they scored a point. If it doesn't equal the die roll, so we go into the else, then we say the player didn't score any points and we don't do anything to the points total. And then we do the same thing below, just for player 2. And we reuse the same player guess variable, because why not? And then, yeah, this is a completed parentheses, C++ in me. Okay. So this plays 1 round of our game. Everything's completed. This the play game. This is our end message. This is plays the game, plays a round. I'll just say plays the game. Number of rounds. Play game function. Or play round function. And then create player objects. Actually, it doesn't really make sense to have a dice class for this. So we'll just have the player class for the player objects. But you could make a dice class. It's just in this situation, we don't really need to keep track of any variables in the die. You could make a class, but it'd be you'd be using more code than you need to. If there were certain variables you needed to keep track of in a die, then you could create it with the class. But or you could do that for extra credit if you wanted to practice your skills. I have no warnings. So class use our function over here, points. Just copy and paste this. Has left. Player 1, player 2 has player 1 dot points left. Okay. And then our end message will say he wins. We're just putting a bunch of new line prints in just to make everything look cleaner at the bottom later. This up. So this should run. So we have our player class. We create 2 players. We enter how many rounds they want to play. We define our play round function. This should really go at the top. Put it below our class. And then, so we ask for the number of rounds. We play our rounds, which we already defined up here. And then there are no more rounds left. We say how many points each player has. Left. And then our end message determines who wins the game. Okay. And then just for playing a single round, we already checked. Okay, so this should run. Okay, so player A, enter your name, so we'll do Michael. Player B, enter your name, Daniel. How many rounds would you like to play? We'll do 5. 7. So we'll do this integer. Okay, Michael enter guess 1. Line 58 in module play round. 24 and 58. 24. Okay, so our die rolls need to be converted to strings for the message. Should go through all our print statements.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Name's always going to be entered as a string. name's always going to be a string. These need to be strings. Okay, try again. Hey, Michael. Player B, player Daniel. How many rounds? We'll do 3. Michael, enter a number guess. 3. The die rolls number 6. He didn't score any points. Daniel, pick a number 4. The die rolls 5. Daniel didn't score any points. Michael, enter a guess. 6. Didn't match. Didn't get any points. Daniel 1. Rolls 4. Didn't score any points. Michael, I want at least 1 success. So we'll do 6 again. 6. Okay. Okay, so we have a bit of an error. The entire program ran, but in the last line, Daniel scored. He should have scored a point. Michael is 0 points. Daniel is 0 points. The game ends in a tie. Okay, so everything worked except for the fact that when Daniel rolled a 6, the die rolled a 6, and we didn't add any points. And Daniel was player 2. I'll just make an add points function. Define add points. Do points plus equals 1. Self.points. Okay. Then we'll do player 1.add points, player 2.add points. We don't need a plus equals. Okay, now let's run again. A, Michael. Actually, I'm gonna need new lines for every round. So we'll do print new line. Run again. Player A, enter your name. I'll do Michael. Michael, player B, enter your name. Daniel. 20 rounds. Do 3 rounds. Michael, enter a guess. 2. 5. Didn't score any points. Daniel, enter a guess. 3. Okay. Daniel didn't score any points. So it's jumping to the else. Player guess 2. I'm thinking it might be because it's reading it as a string, not as a number. Yeah, I think that's exactly why, so we don't need this. Okay, try again. Player A, Michael. Player B, Daniel. How many rounds of rolling? We'll do 2. Michael, please enter a number. 2. Gives 20 points. 2. Gives 20 points. 2. Gives 20 points. Gives 20 points. Play again. Michael, Daniel. 2. 2. 2. 2. 2. Oh, did 5 rounds. Michael, Daniel. 5 or 4 rounds, I guess. Michael and I guess 1. No points. No points. No points. Okay, now it's working. So the error we had before was this condition wasn't being checked properly because our player guess wasn't. It was being read as a string and it is not as a number. So a string is never going to be the same as an integer. So die roll here, it's always an integer because random range always returns an integer or returns a number. Here, player guess, we take it in as a string with the input function. And because of that, we have to turn it into an integer when we're testing our condition. So even though the program ran, we still had a bug, which was we weren't processing when a player was scoring points because we weren't comparing an integer to an integer, we were comparing a string to an integer. So it was like we were comparing the string 6 to the integer 6, which are 2 different things. Okay, so we'll finish our game, just put in some random guesses. Okay. Who scored the points? Okay, Daniel scored a point. Okay, Daniel and Michael each scored 1 point. So this is correct. There are no more rounds left. Okay, and the game ends in a tie. Okay, yeah, everything's correct. So their total number of points was calculated correctly, and then the game ended in a tie because each of them scored a point. And we played 4 rounds. Okay. So just to review really quickly, we imported the random library or the random module because we needed our rand range function, our random.randrange function to pick a random number between 1 and 6. Then we created the player class, which a player has a name and a number of points that they can, total number of points that they can have. We have a print points function, which we use at the very end to display their total points before picking a winner. And then we had our add points function, which adds a point to the player total if they get a correct guess. We have our play round function, which plays a single round of the game. Takes in a player guess. We roll a number between 1 and 6 randomly, and then if the die roll, whatever the die roll is, we print it as a string. And then if the player guess is equal to the die roll, and again we have to put the player guess into an integer because it's taken in as a string. If they're equal, you give player 1 a point, and then you print that they scored a point, and if not, you just print that they didn't score a point, and you do nothing with the point total. And then you repeat for player 2, and then player 1 and player 2 each play their part in 1 round, and then we have our for loop, play 20 rounds of, well, up to 20 rounds of the game. And so we played 4 rounds in our example. And then this is just the main program. So we created our player objects. We asked how many rounds they wanted to play. Then we played that number of rounds using our play rounds function. The player objects are from the class, and then after we play however many rounds we want to play, we print there are no more rounds left, and then we print the player totals, and then our end message declares who wins the game. And because each player only scored 1 point, the game ends in a tie. Okay. So this is our completed guess the rolling dice program. And we will have one more project in our object-oriented programming with Python course. So thanks for watching and have a good day. Bye. Hello, welcome to the last video in our object-oriented programming with Python course. Just as a reminder, before we get to the last project, there's a couple links up here for one-on-one tutoring for object-oriented programming in Python and also software design and engineering. You can find them at our links on our website, and yeah, just copy the links if you're interested. Today we're going to be doing the final project in the object-oriented programming Python course, which is a blackjack game. We're going to be using classes and inheritance to make everything fit together, and yeah, it's going to be a much longer project than the previous two. So just to get started, we need a few classes, so let's make a player class. Let's make a deck class, and let's make a card class. So in our card class, we need a card should have a, let's just say, a face and a suit. So let's do suit, face, self.suit, self.face, suit, face. And deck is going to inherit the card class. So if you're inheriting a different class, you put parentheses and the class that you're inheriting in the new class, and it gives you access to all the member variables and functions of the class you're inheriting, or the parent class. So we want to create a card class that creates cards in the deck, and then we want to fill our deck with those cards. So array. Okay. Card. And then our player class is going to need a name and a score. Let's do points and a score. And then points will be, points is points in the player hands, and score is overall game score.
Thanks for watching. Please like and share this video.
Probably also need a player hand variable that is an array that stores all the cards the player has, but we can add that later. Let's get to the card in the deck class. So the card has a suit and a face, and we need to be able to create all the cards in the deck. So there's 52 cards in the deck because there's the numbers 1 through 10. Then there's the 3 face cards, Jack, Queen, and King. Well, 1 is Ace, but so Ace 2 through 10, and then Jack, Queen, King. That's 13 cards, 4 suits, so 13 times 4 is 52. So we want to create an array in our deck class, and then we want to fill it using the card class. So let's do suits hearts, diamonds, clubs, and spades. We'll do faces, which is ace. I'm going to put the faces as strings, even for the numbers. Just makes things easier because the number value doesn't necessarily mean, well, it means the point value, but we're going to have to change the other cards into point values anyway. So then we need to create our cards. So we'll fill the deck array with loop for x in deck array. Deck array sub x equals let's do it this way. For x in range 52. Deck array sub x equals. So we want to loop through our two lists. And then we want to create a card object. So we'll do a card, and then it's suit and then face. Suit should loop through. So we want to do hearts, 1 through, or ace through king, which is 13 cards. So we want 13 hearts, 13 diamonds, 13 clubs, 13 spades. We'll have card. I'm just going to create a new array. This is how we should do it. Should be for x in range suits, or not x in range suits, x in suits. Y in faces. we'll do deck array equals deck array sub x equals card suits sub x faces sub y. And then, well, deck array, it wouldn't be deck array sub x, but it would be so x and y are the positions. So if we had 4 of diamonds, that would be, suits would be 1, and faces would be 3. But we would need the number so x plus y. If x plus y, it would be 0, 1, 2, 2, 3. So it would loop through all of the faces for hearts. 0, 0 would be the first, 0, 1 would be the second. It would go all the way through, and then this would become 1. So we do 13 times x. Okay, so if x is 0 for suits, then it loops through all of these. If x is 1, then we start at 13. Position 13 would be the next position in the deck array. And then position 13 in the deck array would be position 1, position in suits, and then position 0 in faces. And then we loop through all this, and then, okay. And then if we got to position 52, it would be, spades would be 3, and then faces, so it would be 3 times 13, which is 39. And then we loop through all of this, and then we would get to 51, because it would be 12 plus 39. And that would be our last arcane. Okay. So this is how you set up the array. So we have our just to review really quickly, we have our card class and we have our deck class. So card, just it takes in a suit and a face. It creates card objects, while our deck class creates a deck using card objects. So to create our initial deck, we create for the blackjack game, we created a suits and a faces array that just lists all of the different faces and suits of our cards. And then to create our initial deck, we looped through I guess you don't need to do this. You could just do deck array.append. Okay, we'll come back to this later, but we're just gonna append cards one by one. And using the two arrays. So our so this will create the initial cards for the deck. Haha. This is all we need to do. Okay, so that's how we create our deck array. And then this is going to be our full deck. And then let's just create the, let's start creating the game, and then we can come back to our classes, just so the picture becomes more clear. So we'll define a play game function. We'll ask we'll do play round, and then our main program will have play game. So below our play round function, we'll have main program. So input, welcome to blackjack. But player 1, please enter your name. Player player. Score should be 0. So these two lines will create our two players, and then it will take in the player names as inputs. Just look up some rules in blackjack. So the dealer deals, in blackjack, the dealer deals a card to each player, and then...
Thanks for watching. Feel free to add your questions as comments down below.
Final card to himself, and then his final card is face down. I'll skip a lot of the like the fancy print statements to make it look nice for now. So we'll have the players enter their name, and then the dealer will just start dealing cards. The dealer deals cards, and after the dealer deals cards, we'll do one at a time, and they'll all come from the deck. So we want to get a random card out of our deck array. So we'll need our range function again. Random. And this is where we can have a player hand. Player hand. Variable. Name, self dot points, self score. So just like we appended to our deck array, we'll append to the we'll inherit both the player and the card class for the deck. Trying to think of how we want the inheritance to work. So we want to create a function that deals a card to the player in one of our classes, but it depends on whether we want to put it in whether we want deck to inherit player or player to inherit deck. Put it in deck for now. So define deal card. Appends to player hand. Yeah, we can have deck inherit player. So we'll have self.player hand. Self.player hand, and then we'll append, and then we'll pass it all of our dealt cards. Okay, so we're gonna append, and we're gonna append to the player hand, and we're gonna remove from the deck array. So we're gonna so we have player hand dot append, just a random card from the deck array. So we'll do deck array rand dot range. range, and we'll do 2. We'll remove just store the random number. So number equals random range 2, and then we'll append player hand, and then we'll do deck array sub number card index, view card index. Okay, so we'll pick a random number between 0 and 51. We'll put it in card index, and then we're going to append the card at that position onto our player hand, and then we're going to remove it. We're going to remove it from our deck array. So self.deck array remove self.deck array card index. I don't think the append function removes from the previous array. Yeah, it does not remove from the previous array. So we need an append function to add our new value to our deck array, and we need a remove function to remove from the previous deck array. So so we append a card to the player hand, and then we take away that card from the deck. Okay. And then and then every round we'll reshuffle the deck, so we don't have to worry about running out of cards in the deck. So we'll need a reset deck function. So define reset deck. So in our reset deck function, we'll do we'll just copy this code. Deck. empty list, and then for z and deck array, deck equals deck array. Okay, so we'll create a second deck array, which is a new deck, and then it's going to equal our entire deck array, and then when we reset the deck, we're just going to set x in deck array. Deck array x equals new deck. Okay. So okay. So our reset deck function will take everything in the new deck and we'll put it back. We'll put a copy into the deck array again, and then it'll reset the deck. Okay. So back to our main function, we'll do player1.dealCard. Put deal card in player. And we'll change the inheritance. Okay. Player1.dealCard. Player2.dealCard. And we'll do dealer.dealCard. Dealer equals player dealer. We'll always have start with 0 points, 0 score, and an empty player hand. Okay.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Player 2, this will be dealer. Should be all in the play around function actually. So the dealer deals a card, or deals cards to every player. So he deals 2 cards to everyone. And his second card is face down. Print player1.name gets a face. 1 player hands. Player 1 player hands. Player 1.name gets a player hand 1. And this would be the face of it. This is a card object. So from the card we need the face of repeat this. These. And then we won't have this print statement for the last card because the dealer's card is face down, so we'll just print dealer gets a face down card. Okay. So this will deal 2 cards to every player, including the dealer. And then we'll do to player 1, we'll ask them if they want to hit. If player 1, if input player 1, do you want to dealt a card? Do you want to hit? Okay. That'll be equal to yes. Player 1, do you want to hit? Okay, so if it's yes, player 1 not deal card. So if he says yes, we'll be dealt the card, and then if not, we won't do anything, so we don't need anything else. 2, do you want to hit? 2 dot deal card. And then just make this a while loop. Do if points, some pseudocode, if points greater than 21, player one busts, 2. And then the dealer while dealer Okay, so the dealer has to hit until he has at least 17 points. So while dealer points are less than 17. Okay. So far in our play round function, we'll deal cards. The final card for the dealer will be face down, and then let the player 1 hit until he can't anymore, he busts. Let player 2 hit until he busts, or he wants to stay. And then while dealer points, dealer dot points are less than 17. Just do dealer dot deal card. If dealer 1, or if dealer has more points, okay, so let's just say that a tie is 0 points. So that means if the dealer has less points, dealer dot points is less than player 1 dot points, player 1 dot score plus equals 1. We'll do the same thing for player 2. And then that will be an entire round. So entire round, he deals cards. While this input is equal to y, deal card. Now, because of the way we set up the faces, we can use the position in that array to give points to the players. So deal cards to everyone. Player 1 points less than 22. Same thing down here. So this is how we'll check for bust. We'll make sure the points are less than 22. If player 1 points greater than 22, print break. Player 1 bust. Just do player 1. Okay.
Thanks for watching. Please like and share this video.
I think we'll make just aces count for 1 in this blackjack game, because it could get pretty complicated trying to make it be able to count for either 1 or 2 point values. So, okay, just for our play around function, the dealer deals 2 cards. Dealer deals 2 cards to every player. So everyone gets a card. Then we ask player 1 if he wants to hit, and then we'll use a while loop. So we'll deal a card until points are greater than 21. And then we want to search for the face in our faces array. So, So X in player one basis if player one basis X and player so basis X just do a for loop. Player one dot player hand equals player faces of X. This is checking to see if the card is equal to a position in the faces array. And X is the position. We'll do player one dot points plus equal X. So we'll add the points to the player's points, and then if the points are greater than 21, we'll break. Okay, and we'll copy the same thing for player two. Okay, so we'll fix this code a bit, but that's it for this video. We're just gonna review very quickly the code we wrote. Okay, so we created a card class and we give it a suit and a face. So that's going to be used to create the cards in the deck. We created a deck class that inherits our card class, and we made several variables for it. The deck array is we do not need a delta variable. We do need a new deck. Okay. So we had our card class we used to create a suit and a face. We have our deck class, which inherits card. and it has a deck array, which is going to be used to keep track of all the cards in the deck. New deck, which is going to be used to reset the deck, and then suits and faces, which are arrays that hold all the types of cards that are going to be used to create each individual card. Then we use a double for loop to append all 52 cards to the deck array. Then we create our new deck array, and then we fill it with the same deck. And then every time we want to reset the deck, we just set deck array equal. We assign the values from the new deck array back into the deck array, so that'll reset our deck. And then we also have a player class for variables. So this will create a player with their name, points, which is just like the points in their hand, whatever the card values add up to in their hand. A score, which is going to be like how many rounds they've won. How many rounds they've won. Rounds the players won. And then we'll have player hand, which is going to keep track of all the cards in the player's hand. And then we'll use the deal card function to add a card to the player hands from the deck. So it appends it to the player hand and it removes it from the deck array. And then later we fill out the deck array when we reset. So at the end of our round function, we should actually have a reset deck. Oh, we need a deck object. I guess we don't need a new deck. We could just create a new deck for every round. That would actually make more sense. So we don't need the reset deck function. Okay. So game deck stack. Okay. So yeah, we get through our classes, then we have our play round function, which is going to play a single round of blackjack, and then we'll create like a for loop for how many rounds they want to play. When in our main function, like down here, the play round is going to play a single round of blackjack where everyone's dealt 2 cards, and then the players and the dealer hit. So this deals 2 cards to everyone, and then the second card for the dealer is face down, so we don't tell anyone what it is. Then player 1, we ask them if they want to hit, we deal them a card, and then we see what the point value is, and then we add the points, and if it goes greater than 21, they bust. So they can keep hitting as long as they want until they bust, or until they say no. And then do the same thing for player 2, and then we deal the dealer cards until he has greater than 17. I need some parentheses here because we're going to add an or. So if the dealer's points are less than the player's points, and player 1's points are less than 22, the player wins. But it could also happen or if the dealer busts. Dot points will be the hand. or dealer points are greater than 21, and player 1's points. Okay, so these are the conditions for the dealer to lose and the player to win, and then we'll add points for those two. Okay. Name. Point. So this is our entire play round function. So deals the cards, and then the dealer and the players play against each other, and then if the players beat the dealer, they score points. And then in our main function, we can play a certain number of rounds, and then at the end of the game, we can check the scores. So in our next video, we'll finish the program and then maybe do one more short video after that, just to comment our code and clean everything up. So it's much more clear what everything that's going on throughout the program. So yeah, thanks for watching, and be sure to check out the next video for the next part of the program. Bye.
Hi, welcome to the last video in Coding Bootcamp's object-oriented programming course with Python. This is the second part of our final project, which is the blackjack program. Today I'm just going to go over some modifications I made to get the program to run, and then we're going to do some documentation to explain everything in what everything in the program does, and then if you want to look at the source code for the program, it'll be uploaded onto our website. So yeah, I'm just going to show you what the finished
Thanks for watching. Please like and share this video.
program looks like, so we'll run it. It says, welcome to Blackjack. Player 1, please enter your name. We'll do Dan. Player 2, please enter your name. We'll do Michael. And then enter the number of rounds of Blackjack you want to play. So we'll do 2 rounds. Okay. So the dealer deals 2 cards to every player, and then these are the 2 cards. So Dan gets a 4 of spades, Michael gets an ace of clubs, the dealer gets a 9 of spades. Then Dan gets a 5 of diamonds, Michael gets a king of diamonds, the dealer gets a face down card. So everyone, including the dealer, has been dealt their 2 cards, and then we ask player 1, who's Dan, if he wants to hit. So Dan has a 4 of spades and a 5 of diamonds, so that's 9 points. So the goal of the game is to stay at 21 points or as close to it without going above as close as you can. So if he has 9 points, you'd probably want to hit. So we'll do yes. So he gets a king of hearts. So that means he's at 19 points. So we probably don't want to hit anymore. So we'll enter N for no. And then he'll just stay. Michael, do you want to hit? Michael has a king of diamonds and an ace of clubs. So we only program the ace to have a point value of 1. If you want, you can go back and modify the code after this, after we get through this program, and make it so aces could be 1 or 11 points, like in the actual game. But for this program, aces are just 1. So Michael has 11 points, so he probably wants to hit. He gets a 6 of hearts, so that means he's at 17 points. Let's make him bust, because we want to test to see if one player wins and one player loses. We want a difference of points. We want to see someone win. So we'll just make Michael bust. Okay, so Michael busts, so he loses. Dan should have 19 points. So he got a 4 of spades, a 5 of diamonds, and a king of hearts, so he's got 19 points. The dealer stopped at 17 points after the cards he was dealt. So the dealer got a 9. The dealer's face down card was a 2, so he had 11 points. Then he got dealt a 6 and stopped at 17 points. So Dan wins a round, and then we play our second round. So Dan should have 1 point, or a score of 1. Michael should have a score of 0, and no one else should have any points. So let's just bust everyone else. So yes, Dan busts, yes. Michael busts. The dealer's face down card is a 2 of clubs. The dealer busts. Okay. So Dan has a score of 1. Dan wins blackjack because he won the first round. Now, this didn't affect the outcome of the games. This didn't affect the outcome of the second game because we made sure to bust both players just to test our code. So everything's working except for the fact that we didn't reset our point value when a new round started. So all we have to do is go to the beginning of the play round function and make player 1.points equals 0 and player 2.points equals 0. So I'll just copy this. Player 1.points equals 0 and player 2.points equals 0. So what this is going to do is every time we use our play round function for a new round of blackjack, it's going to reset the player's points to 0. And then we're not, because the reason we got to 38 points and 42 points for Dan and Michael is we added the point totals for the cards from round 2 onto the point totals from round 1. Now it didn't affect who won the game because we made sure to bust both players, but that would affect it going forward. So that's just a small bug. But yeah, that's how the blackjack game plays, and then at the the program prints the point values for the player hands and the dealer's hand at the end of each round, and then awards a score based on who wins compared to the dealer. And then after all the rounds have been played, we print out the score at the bottom, and points is the number of the point value of the hand, the player hands in a single round. So if you have a king of hearts and you have a 7 of clubs, that's a point value of 17. Score is how many rounds the person's won. So that's the difference between score and points. So Dan won 1 round, so he's got a score of 1. Michael won 0 rounds, so he's got a score of 0. So Dan wins blackjack because he won more rounds than Michael, and then the program exits. So that's what our program looks like. And now I'm just going to go over the code really quickly, and we're going to document everything as we do it. Because when you have a lot of code like this, you need to document everything so it's clear what's going on for other people and for yourself if you're going back and making modifications to your code. Okay, so we have a card class. Card class is just used for card objects. Used to create cards in a standard playing deck. Player class is just used to keep track of players and their scores, or their scores and their hands, and the cards in their hand. So I'll just say points is point value of cards in a player hand. Score is number of rounds won. So again, this is why documentation is important, because if you don't document this, it's very confusing what points mean compared to what score means. Because they can mean the same thing if you're not clear about what they actually mean. So our deal card function, it takes in a player object and it takes in a deck object. So it's going to take in a deck as an array because I moved the deck out of the class and I just put it in the play round function, so it's over here. So I decided it would just be simpler to make a deck array for this program because it's small, rather than make an entire class for a deck. So the deal card function is just going to take a card from the player's player hand, like over here. Or no, it's going to take a card from the deck array, which is going to hold all the cards in the deck for a round, and then it's going to put it in the player's player hand, and player hand is over here inside the class. So when you create a player object, that player object is given a player hand, and then that player hand we're going to put in cards using the deal card function. And then every time we put in a card into the player hand, we take it out of the deck. So takes a card out of the deck and puts it in player hand. Okay, and just to review quickly what these 3 lines are doing, we want to pick a card index that's a random card index between we want to pick a random card index from 0 to 51 at the start, but as we remove cards, it's going to be like 0 to 50, 0 to 49, 0 to 48. So we're just picking a random card index of the remaining cards in the deck array. We're assigning it to a variable, and then we're going to use that variable to add that card to the player hand and then remove that card from the deck array. So that's what these 3 lines are doing. This is getting us the random card index, or the random position of the card in the deck array. This is adding the card to the player hand, and then this is removing it from the deck using the pop function. Okay, so play round plays 1 round of blackjack. Print statements are usually pretty self-explanatory, so you don't always have to explain what they're doing. So player 1 points is 0, players 2 points is 0. So we'll just put resets player hand value every round. Our deck array is, anytime there's anything that could be vague about what it means, that's when you should comment. Our deck array is the game deck. We have a suits and a faces array to compare. Suits faces are used to compare cards and find their point value. This creates the deck. This block of code, this deals a card to a player, deals a card to player 1, and gives player 1 corresponding points based on the card they're dealt. They are dealt. Card and points for player 2. I'm just gonna write this as shorthand for what I wrote up here. So card and points for player 2. Card and points for dealer. Then card and points for player 1. Card and points for player 2, and then card and points for dealer. Okay. And this last card, the second card for the dealer, is face down, and then we reveal it later in the game. Okay. So now we have these player 1, player 2, and dealer hit variables. So these are used to keep track of the number of cards added to the player hand. So the reason why it starts at 1 is because 1 is the index of, so I'm just going to put this, keeps track of index of hit cards. So each player at this point in the game has 2 cards from being dealt them at the start of the game. So I assigned 3 variables, the value 1, and I called them player 1 hit, player 2 hit, and dealer hit. And that's the index of the second card in each of their hands. But what we're going to do is, once we get to each player and we have them start hitting cards, we ask, for example, we ask player 1 if they want to hit, if he enters Y for yes, we'll deal him a card, and then we'll increment player 1 hit. So player 1 hit will be 2. So when player hit is 2, that's the index of the third card in the player hand. And then we're going to use that as the index to print the value of that card. So it's going to print the face and the suit. So that's why you see player 1 dot player hands suit and face, and player 1 hit is in as the index. So this is going to print the value of the third card, the face and the suit. And then we're going to compare that third card, the face of it, to our faces array from up here. This is our faces array. I can move this down. I'll move this down here. Actually, that wouldn't be a good idea, because we're using the faces array for other stuff. Keep it up here. So we're going to use this faces array, which we have up here and has the strings for all 13 of our faces for the cards. And then we're going to compare that to the face of the third card we were just dealt. So player hit goes to 3, or no, it goes to 2, which represents the third card that we just dealt up here. We print what that third card is, and then after we print what the third card is, we give a point value to that player based on what the face is. So this represents the face of the third card, and then this represents the corresponding face position in our faces array, which just keeps track of all the possible faces that you could have on a card. So we say if Y is less than 10, player 1 points is you add Y plus 1. So if the face.
Thanks for watching. Feel free to add your questions as comments down below.
This card is like a 3 of spades, or the face is 3. Then we add 3 points because the position of Y is 2. And then 2 plus 1 is 3, and then we add 3 points to the player total. And then if the that's for Y is less than 10, so that's the cards ace through 10. And then for all of our face cards, like king, jack, and queen, we just add 10 points flat. So just to go over this a little bit more quickly, we deal the card, we increment player hit to the index of the new position in the player hand. So at the beginning, player hit is incremented to 2. So 2 is our index, which means it's the third position in the player hand array, which means it's the third card. Then we print what the third card is, which is what you see over here, on the first hit of the first round. So when we ask Dan, do you want to hit, and he gets the king of hearts, this print statement is printing the king of hearts. And it's the third card in the player hand because Dan was already dealt 2 cards. Then we have for Y in range 13. So range 13 is all the possible faces. So there's 10 face values, ace through 10, and then the other 3 are jack, queen, and king. So there's a total of 13. And then we compare. We try to find where in the face array the face of the card we just dealt is. So the king of hearts, that would be position 12 in our array, in our face array. So if we scroll up here, we have ace, 2, 3, 4, 5, all the way up to king. This is position 12. Well, it's position 12, but it's the 13th value in our array. Because all the way up to 10 is our 10th value, jack is our 11th, queen is our 12th, king is our 13th, but it's position 12 because the array is always started 0. So we found that king was in position 12. So because it's in position 12, which is y is the position in the faces array, and y is not less than 10, we go in here and we just award 10 points to the player, based on the king being in his hand. If the player was dealt like a 3 of spades, then 3 of spades would be position 2 in the array, but we need to award 3 points. So if y is position 2, 2 is less than 10, we go in here. We don't want to award 2 points, we want to award 3 points. So 3 of spades, it's position 2, we add 1 to the position, so 2 gets incremented to 3, and then you add 3 points to the player points. So that's how you add points for cards that aren't Jack, Queen, King, and then this else statement is for the ones that are. And then finally, if the player goes above 21 points at any point, we break out of the while loop and we print the player busts. So the player loses the game. And again, all of that's inside of a while loop because we want to allow the player to hit as many times as they want until they go above 21 points or they say they don't want to hit anymore. So this condition will keep testing to see if the player wants to add cards to their hand, and then if the player goes above 21 points, we'll automatically break out of it and they'll automatically lose because they bust. Then we do the exact same thing for player 2. So let's just put some code here. While loop controls adding cards to player hands and assigning point values. And then these would be assigns point values, or assigns points to player based on card added to hand. But busts the player. Okay, and then this adds cards and assigns point values to player. This assigns point values, assigns points to player, and then this busts the player. Okay, so that's player 1 and player 2. So they're done hitting for whatever cards they want, and then now we have the dealer. So we reveal the dealer's card. And then we do the same thing for the dealer. So this is dealer hits until he busts or has at least 17 points. And then this gives dealer points. Whoops. Gives the dealer points based on cards added to hand. And then busts dealer or stops the dealer from getting cards. Okay, this should be indented because it should be part of the while loop. And then we print the points for each player at the end of the round, and then these last two statements, last two if statements, print the players that won and assigns them points, or assigns them a score for winning if they won. Okay, and then this is the main program that plays all of the rounds and creates the player objects. Okay, plays as many rounds of blackjack as the players want. and then determines the winner of blackjack. So yeah, that's how the game works. This is what it looks like. And yeah, just always remember to document your code at the end of a program, or else it's going to be hard for you to see at a glance what exactly code does. So it's not just used for others; it's also used for you if you want to make modifications to code. So there are some bonuses you could do if you want to sharpen your Python skills. You could make the deck object that I just made an array. You could make it into a class. I think in this case it might be a little bit more complicated because we're doing a pretty simple card game, but maybe for more complex card games you'd want a deck class. Also, another thing you could do is there's a lot of repetitive code here. So you could make a function that determines the number of points players are assigned based on the card they're dealt, and then replace this block of code that's repeated with the function. And yeah, that's about it. You could also make the ace values 1 or 11 points, but that would probably add a lot of complicated decisions to the game. And then you could also add how to split cards. So in blackjack, if you get, say, like 2 sevens, like a 7 of hearts and a 7 of spades, then you're allowed to play 2 hands at once and split the sevens into 2 separate hands. That's all functionality you can add to the program. This is meant to show classes and how to use them, but not actually get that in depth into what the game of blackjack is actually like. So yeah, this is our final project. I hope you learned a lot about classes, and thanks for taking the course. Bye.